Hey guys, 9-3, multiplying binomials. This is going to be referred to as foiling for future purposes. Remember, a binomial is a polynomial that has two terms. And this is going to be 2 terms times 2 terms. We are going to skip over example 1 because I prefer to use foiling method. Distributive method is pretty much the same thing. It's just foiling is a mnemonic device that helps you remember to do each and every one. Okay, so foil. Let me see. Okay, so foiling is not aluminum foil, but this means your first terms. This is your outer terms. This is the inner terms. And then these are the last terms. Okay, so the first terms, that would be the 4x and the 3x. So 4x times 3x. And I'm going to go ahead and write this completely out. Outside terms, 4x times negative 6. Then we need to do the inside terms. These two are the inside. 2 times 3x. And then the last terms would be the last terms in those groupings. 2 times negative 6. And here we go. All right, now you're going to get to a point where you are doing some of this mentally and you're not having to write everything down. But at this stage, I want you to write everything down, and I'm going to write it all down so that you can follow along where things are coming from. All right, so 4 times 3 is 12. X times x, there means there's 2, so it's x squared. Okay, that one's done. 4x times negative 6 is going to be negative 24x. 4 times negative 6, negative 24, and then we have that x. 2 times 3x is 6x, and that's positive. And then 2 times negative 6 is negative 12. Okay, now you want to take a look at your polynomial and see if you have like terms anywhere. And we sure do. We won't always have them, but usually we do. Okay, so these are the like terms. So we're going to write 12x squared, negative 24x plus 6. Negative 24 plus 6 is going to give us negative 18. Okay. So now we have negative 18x and then minus 12. And this is your answer. You can't do anything else with it, and you should have 3 terms. Most binomials, most foiling ends up in 3. Sometimes they'll have 4. All right, and sometimes they'll have 2. Depends on what it is. All right, let's do one more, just because we did skip the other example. And you'll notice that each and every one of these has the exact same terms. It's just the signs are changing. So I'm going to go ahead and pick this one just because. 3x minus 4 times 2x plus 5. So the first terms, 3x times 2x, that's my f. So 3x times 2x. My outer, so the 2 on the outside, 3x times 5. My inside terms, negative 4 times 2x. And then my last terms, negative 4 times 5. All right, now we need to combine like terms, clean this up, and let me get a little space there. 3x times 2x, 3 times 2 is 6, x times x is x squared. 3x times 5 is 15x. Negative 4 times 2x is going to give us negative 8x. Negative 4 times 5 is going to give us negative 20. Now looking through, we have an x squared term, an x term, an x term. So like terms, and then a constant. So that's going to be 6x squared. 15x minus 8x is 7x, and then we have minus 20. There you go. Easy stuff, all right? Just remember, multiply everything by itself. As long as you're keeping track of that, and the FOIL method is a really nice way to keep track of that, you'll do fine. All right, example 3. Applying multiplication of polynomials. Okay, so yeah, great. We know how to FOIL now. What's the purpose of it? That would be for all these fun little things right here. Yeah? Okay, so find the area of the shaded region. And these are the type of problems that they like to have on the EOC, the ACT, and all those types of tests because it's a multi-step problem. So they're wanting you to find just this shaded region. That means you have to take into consideration what this is. So there's 2 ways to do this. I think the easiest is to find the area of the larger, so the area of the large, and then subtract the area of the small, and that's going to give you the area of the shaded. Okay, so the area of the large is going to be 3x plus 2 times 2x minus 1. And then the area of the small is x plus 3 times x. All right, and I'm going to put this one in a big bracket. All right, so working with this one here, FOILing, first 3x times 2x, and we've done this one a lot in the recent examples, so you probably know this one by heart already, but I'm just going to go ahead and write it out like I said. So 3x times 2x, outside 3x times negative 1, and then we have inside 2 times 2x, and then we have 2 times negative 1. All right, cleaning house, right? Cleaning everything up. 3 times 2 is 6. X times x is x squared. That one is done. 3x times negative 1, that's going to be negative 3x. 2 times 2x is 4x. And then 2 times negative 1 is negative 2. Negative 3x and 4x are like terms. So that's going to be 6x squared. 4x minus 3x is an x. And then we have minus 2. Okay, so now that part is done. Now we need to address this. I would take the term outside and multiply it, distribute it to the terms that are inside. So that's going to give me, and I'm going to put this right here underneath this blue line. I'm going to look at it like this instead of the other way. So x times x is x squared, and x times 3 is 3x. Okay, so now in order to find that shaded region, we're going to take the entire large area, which is right here, and subtract the smaller area, which is right there. So 6x squared plus x minus 2, I'm going to rewrite it so that it doesn't all go together. That is horrible. Don't. It is not very pretty. All right, so we have 6x squared minus x squared. We can distribute that negative, right? This becomes negative x, negative 3x. We change it to a positive, adding the negative, adding the opposite. 6x squared minus x squared is going to be 5x squared. So those are done. X minus 3x minus 2x. Those are done. And then minus 2. So there you go. There is the area of your shaded region. And this is in simplest form, so you are good. Good stuff, right? All right, let's go ahead and do the last example. multiplying a trinomial and a binomial. Now, I want you to read this part here. FOIL works when you multiply two binomials, and that's the only time it works, okay? Any other time, you're going to have to use just straight up distributive property, right? So, now, there is a vertical method and a horizontal method. I have always done the horizontal method. I have tried teaching the vertical method, and it was okay, but I think I'm just so ingrained with doing the horizontal that that is where my expertise lies, if you will. So I'm going to show you that one, and if you want to see the vertical method, we can do that in class, or if I have time, we can do it here, okay? All right, so we are going to do 3x squared minus 2x plus 3 times 2x plus 7. Okay, so the first thing I want to do is distribute this 3x squared to the 2x. So that's going to be 3x squared times 2x, 3x squared times 7. Then we have negative 2x. Make sure you're treating that as negative 2x. Negative 2x times 2x. Thought I did something wrong there for a second. Negative 2x times 7. 3 times 2x. I'm running out of room, so I'm going to go ahead. 3 times 2x. Let me see if I can grab all of this and move it down. Ah, fantastic. Love having the smartboard stuff, huh? All right, and then finally, 3 times 7. All right, so now time to clean and set everything straight. 3 times 2 is 6. X squared times x. So remember that's 2 x's here and that's an x here. So now we have 3 x's. So x cubed. 2 plus 1 is 3. 3x squared times 7. So 3 times 7 is 21. And that's x squared. Negative 2 times 2 is negative 4. X times x is x squared. That one's done. Negative 2x times 7 is negative 14x, because negative 2 times 7 is negative 14, and just that simple x. 3 times 2x is 6x. 3 times 7 is 21. Now we want to combine like terms. So we've got these two, and we've got these two. This is going to be 6x cubed. 21x squared minus 4x squared will give us 17x squared. Negative 14x plus 6x, negative 14 plus 6 is negative 8, and then 21. And this is your answer, okay? You can't combine anything else. X cubed, x squared, x, and a constant. Those are 4 different terms, so that's it. All right, I'm going to go ahead and end this now, and if I have time, I'll do an example of this vertically on a different video.